Hey everyone, and welcome back to another Explainer. Today, we're undertaking a seriously fascinating exercise in software craftsmanship. We're going to literally put on our surgical masks and dissect a single piece of code. Specifically, we'll be diving deep into Chapter 16 of Robert C. Martin's legendary book, Clean Code. We're going to track the complete transformation of a class called SerialDate, and as you'll see, we're going to learn exactly how perfectly competent, functioning code transforms into truly clean, professional code.
For this explainer, we're conducting a professional review of the SerialDate class from the widely used JCommon library. And I want you to think about this process exactly like those meticulous, routine reviews done by doctors evaluating patient charts or pilots going through those rigorous post-flight debriefs. It's a genuine exercise in professional craftsmanship, absolutely not a witch hunt. In our profession, looking closely at how things are built is simply how we elevate our standards.
Okay, let's dive into this. We've all been there, right? Have you ever opened a file someone else wrote, or, let's be honest, maybe even code you wrote a year ago and just felt an immediate headache coming on? Even well-written, totally functional code can contain these hidden bugs and structural smells that absolutely frustrate future developers. This image perfectly captures that universal feeling of confusion and annoyance we all get when trying to untangle inherited logic.
Which brings us to the ultimate question, really. How do you improve code that already works? How can a developer confidently go in and alter functioning code without breaking the entire system? It's a terrifying prospect for a lot of people, for sure, but there actually is a deliberate, repeatable process to do it safely. So, here is our roadmap for today. We're walking through a structured, two-phased technical methodology. Number 1, the professional code review. Number 2, first, make it work. Number 3, then make it right, and finally number 4, the Boy Scout rule. Let's start with Section 1, the professional code review. This is a fundamental requirement. We're reviewing the work of a highly competent creator, David Gilbert. And again, we're doing this not out of malice, but because critiquing and improving is literally how our whole industry learns.
And that brings us to Section 2. First, make it work. We absolutely have to weave a safety net. Before we can perform any surgical refactoring, before we change a single variable name, we stabilize the code with automated tests. You simply cannot refactor without absolute confidence that you aren't breaking existing behavior.
Now, what's really interesting about this metric is our starting point. When the author of Clean Code ran a coverage tool on the existing tests for SerialDate, the initial test coverage was this patchwork quilt of only about 50% of the executable statements. Basically, half the code was entirely untested. If you start moving things around with only 50% visibility, well, you're essentially performing surgery in the dark. So, to build that safety net, completely independent unit tests had to be written to push that coverage way up. And in doing so, some really fascinating things were exposed. By testing rigorously, hidden boundary condition bugs were discovered in code that supposedly worked. For instance, there was this wild bug where if December 25th fell on a Saturday, the system actually failed to calculate the correct following Saturday. Another algorithm completely failed if the nearest day queried was in the future. There were unexecuted boundary condition statements just sitting there, completely untested and totally broken.
But by meticulously testing and fixing these boundary logic errors first, the test coverage was pushed to a highly secure 92%, and that is a massive victory. With 92% of the executable statements covered by passing tests, we finally have the safety net required to confidently change the structure of the code. We made it work. Now,
we can move right into Section 3, then make it right. This is the fun part, the surgical phase. With our safety net of tests completely secured, we aren't changing what the code does anymore, we are changing how it communicates its intent to the next human being who has to read it. Let's look at the very first thing that was changed, the name of the class itself. Changing the original name from SerialDate to the refactored name DayDate. This fixes the level of abstraction. You see, the term serial implied an implementation detail, that it was based on a serial number of days since 1899. But as an abstract class, it shouldn't reveal implementation details. Plus, serial is just kind of inaccurate nomenclature. DayDate is a far cleaner, much more precise name for a class that deals with days and dates rather than time.
Next, we look at the data types. The original code inherited a bunch of integer constants to represent months. Swapping those fragile constant integers for a modern month enum is an absolute game changer. Why? Because an enum entirely prevents invalid inputs. You literally can no longer pass a 13 into a month argument. No way. By doing this, all the messy, cluttered error checking methods that verified if a month code was valid, they could be entirely deleted. The type system just does the work for you.
Then there's the whole issue of comments. The original file had these massive Java docs and changelogs detailing every tiny modification since 2001. Today, redundant Java docs and old journal comments are just visual clutter. Worse than that, they're places for misinformation to gather, because comments inevitably fall out of sync with the code over time. With modern source control systems tracking our changes, deleting these massive comment blocks is simply the cleanest, most professional option. Explain yourself in the code, not in the comments.
And this brilliantly illustrates how we execute these surgical improvements. We go method by method. It means encapsulating messy conditional logic into clearly named methods. It means pulling abstract methods up the class hierarchy where they actually belong. It meant taking complex math equations and breaking them apart using explaining temporary variables. By doing this, suddenly duplicate if statements disappeared entirely, and the algorithms became instantly readable.
Let's move on and see how this builds to a rather surprising result. After all that intense refactoring, renaming, and extracting, we run our test coverage tool again, and the coverage actually dropped. From our secure 92%, it went down to 84.9%. Now wait a minute. We didn't delete any tests, so why on earth did our coverage percentage drop?
So the crucial point is, the explanation is actually a complete plot twist. The coverage percentage only dropped because the massive cleanup drastically shrank the overall size of the class. By eliminating redundant code, deleting obsolete error checking, and fixing structural bloat, the total number of lines absolutely plummeted. The only lines left uncovered were so incredibly trivial that they simply weren't worth writing tests for. A lower percentage of a much smaller, significantly cleaner class is actually a massive win. Which brings us to our final section, the Boy Scout rule. This is really the core of code maintenance, and the professional mindset every single developer should adopt.
Leave the campground cleaner than you found it. This is the Boy Scout rule, and it directly applies to software engineering. Think about it. If every programmer checked in a module of code just a little bit cleaner than when they checked it out, code-base rot would be practically impossible. The system would actually get healthier over time rather than degrading into some tangled, unreadable mess.
And honestly, the best part is that the cleanup doesn't have to be a massive multi-day refactoring effort like the one we just looked at. Small cleanups matter immensely. Incremental steps are enough to uphold the rule. Change one poorly named variable for the better. Break up one function that's gotten just a little too large. Eliminate one tiny bit of duplicate logic. Extract one composite if statement into a readable method. It takes, 5 minutes? But it pays compounding interest to everyone who touches that code after you.
So I want to leave you with this question. What legacy are you leaving in your code base today? Are you just making it work and then stopping? Or are you taking the time to weave that safety net of tests and then making it right? I really challenge you to apply this two-step refactoring process and the Boy Scout rule to whatever you're working on right now. Leave your code cleaner than you found it. Thank you so much for joining me on this explainer, and I'll catch you next time.